This looks like a simple clay jar, nothing special. No wires, no gears, no electricity. But drop a coin inside and it automatically pours out wine or holy water 2,000 years ago. So how did a vending machine exist long before the modern world was even imagined? The Roman Empire wasn't just about armies, roads, and emperors. Hidden behind temples and stone walls was technology so advanced, we're still trying to catch up. This is the advanced tech of the Roman Empire, and the forgotten machines that almost changed history forever. Most people think Rome conquered the world with swords, soldiers, and stone roads. That's only half the story. Behind the legions and marble statues, the Romans were quietly building systems, machines that moved on their own, structures that repaired themselves, and mechanisms that followed rules instead of human hands. This wasn't trial and error. This was applied science. They understood pressure, gravity, flow, rotation, and timing, not as theories, but as tools. Tools used in temples, cities, factories, and everyday life. What makes this unsettling is not what they built, but how early they built it, because some of these ideas wouldn't return to human history for another 1,500 to 1,800 years. And to understand how this was even possible, we need to look at the mind behind many of these machines, a man whose ideas were centuries ahead of the world around him. To understand how Rome built machines that feel modern even today, we have to start with one man, Hero of Alexandria. Hero lived in Alexandria, one of the greatest centers of knowledge in the ancient world. This was a city of libraries, mathematicians, engineers, and astronomers. And Hero stood at the intersection of all of it. He didn't believe technology needed electricity. He believed it needed understanding. Understanding how air behaves when heated, how water moves under pressure, how weight can be turned into motion, how motion can be controlled. Hero wrote detailed descriptions of his machines, not as fantasies, but as instructions, step by step. Many of his ideas look so modern that historians still struggle to accept their age. What's strange is this: Hero never thought he was inventing the future. To him, these machines were just clever solutions to practical problems, and that may be the most unsettling part of all. When fire opened doors. Now imagine entering a Roman temple. In front of you stand massive bronze doors, heavy enough that several men would be needed to move them. A priest steps forward and lights a small fire on an altar beside the entrance. Moments later, the doors begin to open, slowly, smoothly, with no human touch. To the average Roman citizen, this looked like divine power. To Hero, it was physics. Hidden beneath the altar was a sealed system of air and water. When the fire burned, the air inside the container heated up and expanded. That expansion increased pressure, forcing water through a pipe into a separate vessel. As that vessel filled, it became heavier. That weight pulled on ropes. The ropes rotated metal poles, and the poles turned the doors open. When the fire went out, the air cooled, pressure dropped, the water flowed back to its original container, the weight lifted, the ropes loosened, the doors closed. No servants, no reset button. The system corrected itself. This wasn't a trick. It was an early example of automation, a machine responding to changes in its environment. The steam engine that came too early. But Hero's most important invention wasn't hidden in a temple. It sat openly on display. A sealed kettle was placed over a fire. As the water inside boiled, steam traveled upward through pipes into a hollow metal sphere mounted on pivots. The sphere had two small nozzles on opposite sides. When steam escaped through those nozzles, the sphere began to spin. This was not decoration. This was rotational power created by steam. The same idea that would later power factories, trains, and cities already existed nearly 2,000 years ago. But the Romans didn't connect the dots. They had cheap labor, they had slaves. They didn't need machines to replace human work. So the steam engine was treated as a novelty, a clever demonstration, something to admire, not to apply. History rarely misses opportunities like this, but when it does, the consequences echo for centuries. Because buried inside Hero's spinning sphere was the seed of the modern world, and no one realized it until it was far too late. Modern buildings crack, weaken, and collapse in just a few decades. Yet Roman structures have survived earthquakes, floods, and 2,000 years of time. This wasn't luck, and it wasn't overbuilding. The Romans invented self-healing concrete. Their mix wasn't smooth or perfect like modern concrete. In fact, for years, historians thought it was poorly made. But that mistake turned out to be genius. They mixed volcanic ash, sand, water, and chunks of quicklime, and then combined them at extremely high temperatures. Those lime chunks stayed dormant inside the concrete. When cracks formed and rainwater entered, something incredible happened. The water reacted with the lime. A chemical reaction started. New minerals formed and spread into the cracks. The structure sealed itself. In modern tests, cracks in recreated Roman concrete completely closed within weeks. No repairs, no human intervention. This single invention unlocked architecture the ancient world should never have been able to build, including the Pantheon, still the largest unreinforced concrete dome on Earth. Even today, engineers study it, not to admire the past, but to learn from it. Before clocks, time depended on the sun. Cloudy day, time disappeared. The solution didn't come from electricity or springs, it came from water and gravity. Water flowed at a controlled rate into a container. As the level rose, a floating marker moved upward, pointing to the current hour. At the end of the day, instead of overflowing, the water triggered a siphon, the system emptied itself, and the clock reset automatically. But the real genius was deeper. The Romans knew daylight changes with seasons, so gears adjusted the display over time, compensating for longer and shorter days. This wasn't just a clock. It was automated timekeeping, accurate enough to run courts, markets, and daily life without a single moving part powered by humans. Time was no longer guessed. It was engineered. Rome's forgotten factories. Feeding massive cities required more than farms. It required machines that worked non-stop. In southern France, archaeologists uncovered a Roman flour mill complex unlike anything seen before. 16 water wheels, arranged in a cascading sequence, powered by aqueducts. Water turned the first wheel. That wheel powered the next and the next. Grain entered at the top. Flour came out at the bottom. Every single day, this system produced up to 25 tons of flour, enough to feed an entire city. Only about 30 workers were needed to keep it running. This wasn't a workshop. This wasn't clever engineering. This was industrial-scale production, a factory, centuries before the word even existed. And it raises an uncomfortable question. If Rome understood automation, power systems, precision engineering, and mass production, how close were they really to a technological revolution the world wasn't ready for yet? Next, we go smaller, impossibly smaller, and uncover Roman technology so precise it still shocks engineers today. Not all Roman technology was massive. Some of it was uncomfortably precise. In 2023, archaeologists uncovered a Roman lock made of gold, small enough to fit inside a jewelry box. It was barely larger than a modern bottle cap. Yet inside it was a fully working locking mechanism. Insert the key, turn it, internal pins shift, a chain releases. Functionally, it worked almost exactly like a modern padlock. This wasn't cast as one solid piece. It was assembled, aligned, balanced. Every part shaped by hand, without microscopes, without power tools, without modern measurement systems. Even today, recreating something that small with moving parts requires extreme precision. The lock wasn't meant to impress the world. It was meant to protect something personal. And that's what makes it disturbing. Roman engineers weren't just capable of big ideas. They had mastered miniaturization, the first vending machine in history. Then comes the invention that feels the most out of place in time. A machine that sells something automatically. You drop a coin into a slot. The coin lands on a small tray. Its weight tilts a lever. The lever opens a valve. Liquid pours out. As the coin slides off the tray, the valve closes again. Exact amount every time. No electricity, no springs, no human control. This machine dispensed holy water and wine inside Roman temples. It ensured fairness. No cheating, no overpouring. The idea was so ahead of its time that it vanished from history, only to reappear nearly 1,800 years later in modern vending machines. Same principle, same logic, different century. The future had already been designed, it just wasn't adopted. Put all of this together: self-correcting systems, automation, steam power, factories, precision engineering, standardized mechanisms. The Romans didn't lack intelligence. They lacked pressure to change. Cheap labor replaced machines. Tradition slowed innovation. Spectacle replaced application. And so the world waited for centuries. The unsettling truth is this: the modern age wasn't born suddenly. It was delayed. Because long before factories, engines, and automation reshaped the world, the Roman Empire had already figured out how it could be done. They just never realized what they were holding. When the Roman Empire collapsed, its technology didn't slowly improve or transform into something new. It vanished. Not because the machines stopped working, but because the systems that supported them disappeared. Engineers were no longer trained. Workshops closed. Aqueducts fell into disrepair. Manual labor replaced automation. The most dangerous loss wasn't metal or stone. It was knowledge. Hero of Alexandria's writings survived in fragments, copied by monks who often didn't understand what they were preserving. Machines that relied on pressure, flow, and balance became myths, then curiosities, then footnotes. For hundreds of years, humanity walked past ideas that had already been tested and started again from zero. That's the part history rarely tells you. Progress is not guaranteed. It's fragile, reversible, and easy to lose. Think about what the Romans already had. They understood automation. They understood feedback systems. They understood mass production. They understood steam power. They understood precision engineering down to the size of a coin. What they didn't have was urgency. Cheap labor made machines optional. Tradition slowed adoption. Innovation existed, but scale didn't follow. So instead of factories powered by steam, the empire stayed dependent on human bodies. And when the system collapsed, there was nothing resilient enough to carry that knowledge forward. The Industrial Revolution didn't begin because humans suddenly became smarter. It began because the world finally needed machines. Rome had the ideas, but not the pressure. The Romans weren't primitive. They weren't lucky. They weren't guessing. They were engineers. And their greatest legacy isn't just roads or ruins. It's a warning. Technology alone doesn't change the world. Adoption does. A civilization can stand on the edge of a revolution and still walk away from it. If this shocked you, you're not alone. History is full of futures that almost happened. If you enjoy uncovering the forgotten technology, lost inventions, and hidden truths of ancient civilizations, make sure to subscribe and stay with the channel. Because the past is not as simple as we were taught, and sometimes it's far more advanced than the present is willing to admit. The next story might change how you see history forever.